All right, next we have next we have our friend from the Republic of Korea here, Mr. Jihan CHUN. Jihan CHUN? It wasn't the Finnish names that are giving me trouble. It's the Korean ones. That right there. Thank you, sir. All right.
Oh, it's in Finnish. Nice.
Thank you. Okay. My name is Jihan CHUN from Korea Atomic Energy Research Institute. Since I entered university, I have been studying and working in the nuclear field all the time for 30 years. But however, it is my first time to be invited to present by environmental NGO. So thanks giving me very unique and good experience. So I was requested to present smart development status. So this is content of my presentation. Okay, first of all, I will introduce the smart general description. The second, I will describe development history of smart. You can understand how the smart has been developed. Third, I will talk about the main technology of smart. Finally, and then I will touch the district heating application very briefly. So, and then finally, I summarize my presentation. Okay, please allow me to get started with smart generals. Smart is an integral type PWR small modular reactor with 365 megawatt summer. It is multi-purpose reactor for the electricity generation, district heating, or desalination. Smart is estimated to supply electricity and hot water for about 15,000 households. Okay, smart is integral type reactor, so all of main components are installed in one vessel. So the detailed description will be described in the following slides. However, I'd like to emphasize one point here. The smart inherently eliminates large breakthrough, and it's designed not to uncover the core during the small breakthrough. Okay, this slide shows you the development history of smart. The smart has been developed by KAERI since 1997. We have very important two achievements here. First is the smart standard design approval and smart pre-project engineering with KAERI of Saudi Arabia. The smart got standard design approval in 2012. The KAERI designed the small modular reactor with 330 megawatt summer, and we issued the safety analysis report and a lot of related documents. At the time, during the SDA, we performed around 40 experiments. All of smart specific technologies were validated using those experiments. The 1.5 years were needed only for licensing review. At the time, around 2,000 technical questions were resolved. So finally, the smart was granted to satisfy all of Korean regulations by Nuclear Security and Safety Committee of Korea. Unfortunately, the Fukushima accident occurred during the SDA phase. So SMART was also requested to enhance its safety. So as you know, Fukushima accident is one of station blackout, loss of all of electric power. So KAERI introduced the fully passive safety system into the SMART after SDA. In the SDA design, only passive residual heat reverse system was passive. other safety systems, such as safety injection system and containment cooling system, were active system. So after SDA, we changed all of safety system to passive. So current smart design adopts the fully passive safety system. After that, we performed the smart pre-project engineering with the KAERI of Saudi Arabia to construct the smart in Kingdom of Saudi Arabia. So we redesigned the smart with the full passive safety system and with the site information of Saudi Arabia, and we increased the summer power by 10%. So the summer power smart, current summer power smart is 365 megawatts summer. Finally, we issued preliminary safety analysis report and preliminary accident management program as a final result for the construction permit in Saudi Arabia. As one of very important program of smart PPE, we had human capacity builder program for the KAERI engineers. So more than 40 KAERI engineers had stayed at KAERI in Korea for 3 years, and they have been trained entry press design. Smart PPE is the first phase of smart partnership cooperation between Korea and Saudi Arabia. So we will continuously cooperation for the construction of smart in Saudi Arabia and for exportation to other countries. Okay, here I'd like to show you a very short video clip to demonstrate the structures and system of smart. Did you enjoy this video clip?
Yeah, you need kind of Dolby surround.
Yeah. Yeah, okay. Okay. So as I mentioned in the right before, after SDA, we changed all of safety system to passive and increased thermal power by 10%. So that means the current smart design is different from the smart design which got standard design approval. So KAERI and KAERI and KHMP decided to do the standard design change approval now. So the main purpose of SDCA is the safety of smart with fully passive safety system is approved by regulatory body. This project will be started next month, from next month. So I think it is very useful for the exportation to other countries. Okay, please allow me to explain the main technology of smart. First of all, I'd like to introduce the top-tier requirements. For the general requirements, the smart is integral type PWR with 365 megawatts summer. The plant lifetime is 60 years. The plant availability is more than 90%. Reload cycle is more than 30 months. Spent fuel storage capacity is 60 years and additional 1 per core. For the safety-related requirements, the smart adopts fully passive safety system for accident mitigation. The core damage frequency is less than 10 to minus 6. Containment to failure frequency is less than 10 to minus 7. The operator response time is more than 72 hours. The seismic design is based on the 0.3G. This is a reactor base assembly. As I mentioned in the introduction, the smart is an integral reactor. So all of the main components are installed in one vessel. So we don't have a large RPV penetrations. All of RPV penetrations are less than 2 inches. So, that's why there is no large break roca in smart. So this point, okay. This is in-vessel steam pressurizer, and we have 8 helical steam generators here. There are four the reactor coolant pump there. This is core, including 57 fair assemblies with the standard 17 by 17 UT fair. Okay. This slide demonstrates the philosophy of passive safety system of smart. Those are to maintain reactor in the safety condition for 72 hours without any operator action at the postulated design basis accident. All safety system can operate not depending on electric power for 72 hours. The safety grade batteries provide the necessary DC power only for valve initiation and post-accident monitoring. This is a schematic of a passive safety system. This is PRHRS, which is removed laser heat by natural convection. We have 4 trains of PRHRS. This is passive safety injection system. We have 4 trains of passive safety system. Each system consists of the 1 core makeup tank and one safety injection tank driven by gravity. This is containment pressure and radioactivity suppression system, which replaces the containment spray system installed in the commercial large nuclear power plant. So originally we have IRWST with a very large inventory of water. So main concept of CPRSS is to suppress pressure and radioactivity by sparging the mass and energy into the large inventory of water in the IRWST. So during the accident. Okay, all of smart smart specs technology were validated using the various experiments like that. So through the SDA phase and the safety enhancement phase and the smart PPE. We also have the smart ITL, which is integral test loop. There's our so that we can to demonstrate the various accident scenarios. Okay, let me introduce district heating application very briefly. Actually, I was not interested in the district heating application before I was invited to this seminar, because most of households in Korea use natural gas directly. And our first partner is Saudi Arabia, and we are recently we performed the feasibility study for the construction smart in the Jordan. In these countries, the heating is not a big issue. They are more interested in the desalination using the SMR. So I'm not the specialist for the district heating. So
use it for cooling.
Yeah, right. So I think so this is a very brief idea. So I think the small modular reactor, including smart, is very suitable more suitable for the district heating than large nuclear power, because the small modular reactor can be deployed in the civil area because of enhanced safety and small system. So we can in order to apply district heating, the existing the condenser in the secondary side of smart can be replaced by heat exchanger to produce hot water, like this. This is scoping analysis, very briefly scoping analysis. This calculation, please understand, this calculation is based on the 330 megawatts summer. If you get the data over the 365, you can easily add 10% simply. When we consider Korean peak electricity and hot water consumption data, smart can generate electric power of 82 megawatt electric and hot water of 147 gigacalorie per hour. It can supply electricity of hot water for the 15,000 household. Okay, this is before I arrived here, I just thinking about what is the safety issue for the application of the district heating. So I think there is no any concern about LOCA, because there is no any direct connection with RCS. However, we have some safety issue for the secondary side. The secondary heat level increased due to the steam flow surge to the direct heating system, the turbine trip due to operational disturbance related to direct district heating system, and loss of load due to sudden stop of district heating system. However, I think this is in my personal opinion. Originally my major is safety analysis. So in my personal opinion, those events, most of those events are bounded other conventional event in the secondary side. So I think there is no any significant safety issue for application of district heating. Okay, finally I'd like to summarize my presentation. The safety of smart with active plus passive safety system was approved by regulatory body. After then, we enhanced its safety by introducing the fully passive safety system and increase some power. And we already prepared to construct the SMART in the Saudi Arabia. So, and the SMART or the SMR, including SMART, is more suitable for the application of district heating than large reactor. This is my conclusion. Thank you.